In this video, we're going to be graphing the sine and cosine parent functions. Parent functions are like the functions that nothing's happened to yet, like it hasn't been shifted left or right, up or down. When you did linear functions, the parent function would just be like y equals x. When you did quadratics, the parent function is y equals x squared. So like it's the very basic form of the equation. So in this video, we're going to graph both the sine and the cosine parent functions. And then I'm going to give you some notes about some of the key features of the parent functions. And then as you're watching it, you're going to graph the parent functions on your homework and also take some notes, and then you'll be doing some transformations of these graphs and coming up with what you think the rules are. Alright, so we're going to start with y equals sine of x. Now if you go back to like 6th grade, when you know really not much about what the graph of a function looks like, you would start off by making a table. So we're going to make the table using the unit circle. So we're going to make as big of a table as we can. Here's the x, here's the y. And I'm going to use for x values in degrees the angles that are on the unit circle. So I'm going to have 0 degrees, I'm going to have 30 degrees, 45 degrees, 60 degrees, 90 degrees, and I'm just going to speed this up with writing it. Okay, so I just filled in the rest. So this is really just going around the unit circle one time. So I am going to basically plug in the value that I have in my table for x. Okay, so sine of 0 degrees is 0. Then I'm going to keep doing this for each degree value. So I'm going to keep plugging in. Sine of 30 degrees is 1/2. Sine of 45 degrees is root 2 over 2. And I'm going to keep doing this all the way to the end. So all I'm doing is plugging in the values. Okay, so I kept plugging in, and these are the values that I get. Now I'm going to have to plot them as points on my coordinate plane that I have already here. So it's not going to be so easy to graph them all, right? These are irrational, root 2 over 2 and root 3 over 2. You could get decimal equivalents, so I'm going to just estimate them for the purposes of this graph, even though we know those are not exact values. But I still want to be able to estimate where they would go. So root 2 over 2 is approximately 0.7, and then root 3 over 2 is approximately 0.866. Okay, so I'm going to now plot the points the best that I can on this coordinate plane. So I have the point 0, 0. Notice my x is theta, it's my degrees, it's my input, and my y is my output, what I get for the sine. So 0, 0 is a point. And then I have 30 degrees. Notice that the x-axis is going by 10 degrees at a time, so 30 degrees would be the third tick mark here. So 1, 2, 3. And then the y-axis is going by tenths. So the fifth one up would be 0.5, which is equivalent to 1/2. So we have 1, 2, 3, 4, 5 here, so this is 0.5. So at 30 degrees, I have a point at 0.5. Okay, and then these are approximations, but 45 degrees would be around here, and then 0.7-ish, so that's going to be around here, and then 60 degrees would be around here, and it's 0.8, so somewhere 0.866, somewhere up there. Okay, 90 degrees is going to be easier to graph because that's just 1. Okay, then it kind of like reflects itself, right? It kind of mirrors the image now, because at 120 degrees, which is right here, it becomes 0.866 again, so it's going to be here-ish. Okay, and then we get to 150, and you could graph also the in-between points, but I'm trying to get the ones that I know for sure. 150 is 0.5, so that's easier to graph. And then at 180 degrees, you have 0. Okay, and now at 210, which is around here, we're at negative 1/2 or negative 0.5. So 1, 2, 3, 4, 5. So this is negative 0.5. At 210, we're here. Okay, and then again, you have those other points. So it'll be like negative 0.7, which is around here-ish. And then you have at 240 degrees, you have negative 8.866. So it's around there. But then at 270, you have negative 1. So that one's easy to graph. And then I'm going to skip ahead to 330 because that's at the halfway mark again. And I know that that's negative 1/2, so I'll be here. And then at 360 degrees, I'm back at 0. So you get a graph that looks like this. Okay, obviously it should go through your points. Okay, there we go. All right, so what happens when we go past 360 degrees? So what would happen if I wanted like 450 degrees to be on my graph? So then I would have y equals sine of 450 degrees. Okay, so if I wanted sine of 450 degrees, that's coterminal with 90 degrees, so that becomes 1. So I'm back up at 1. Okay, what happens at 540 degrees? Okay, let's check. So what is sine of 540 degrees? So sine of 540 degrees, well, that's coterminal with 180 degrees. So that's going to be 0. So then that gives me the point 540 degrees, comma 0. Is right here. Okay, now you could probably guess that 630 degrees you're going to be at negative 1, and you are. Sine of 630 degrees is negative 1. And then at 720 you are back at 0. So actually this curve continues in the exact same way. And it would go in the exact same kind of pattern in the other direction. If I went into my negative angles, because those are coterminal with 0 to 360, I can figure that out, and it's going to do the same thing over here. Okay, and this will do the same thing this way, right? This could keep going. So that's the sine graph. Now let's see what happens with the cosine graph. Okay, so now we're going to do the same thing for cosine. The parent function for cosine is y equals cosine of x. We're going to take our degree values that are on the unit circle and plug it in for x and get the corresponding y value. So for the first one, what I'm doing here is I'm plugging in 0 degrees for x. So I'm finding what is the cosine of 0 degrees. The cosine of 0 degrees is 1. Then I do it again for 30 degrees. The cosine of 30 degrees is root 3 over 2. And I'm just going to fill this in. Again, I'm just using the unit circle, figuring out what the cosine value is for each of these angles. Okay, now that I have all of my points, I figured out the cosine of all of the angles, I'm going to start plotting the points, just like I did before with sine. I'm going to still use the approximations, and then eventually I'm just going to use the halves, zeros, and ones. So to start off at 0 degrees, we have a point at 1. So the point is 0, 1. Then remember that root 3 over 2 is approximately 0.866. So at 30 degrees, I'm going to go to approximately 0.866, which is somewhere around there. Root 2 over 2 is approximately 0.7. So at 45 degrees, I'm going to go to 0.7, sort of there. At 60 degrees, which is right here, I'm going to go to 1/2. So that one I know where to put it. So 1, 2, 3, 4, 5 for 0.5. And here we go. And then 90 degrees is 0. Okay. Then at 120, right around there, we're at negative 1/2. So that's a negative 0.5. So we are somewhere here. Okay, and then it keeps going, right? I have the approximated values, and then at 180, I'm at -1. Then at 240, you could put in the approximate values as well. I'm just trying to speed this up a little and get the ones that I could definitely put on a direct intersection on the coordinate plane here. So at 120, I'm at -1/2. Sorry, 240, I'm at -1/2. And then at 270, I'm back at 0. Okay, and then at 300, I'm at 1/2 again. And then at 360, I'm at 1. Now remember that I could get coterminals with these, right? So for instance, at 450, let's see what's going to happen. Cosine of 450, well, that's coterminal with 90. So at 450, this is equivalent to 0. So I'm going to be back here at 0. What happens at 540? Okay, well, 540 is coterminal with 180. So that means the cosine of 540 is -1. What about cosine of 630? 630 degrees is coterminal with 270 degrees, so that's going to equal 0. And then cosine of 720 is coterminal with cosine of 360, or cosine of 0, so that's going to equal 1. So back up here. So again, we have a very similar shape to the sine parent graph, but there are some differences, and we're going to talk about the differences in the next page. Okay, so when we typically graph the parent sine and parent cosine function, we're only going to do usually the 5 key points, I call them. I'm going to show you them in both directions, and I'm going to show you them in both degrees and radians. So this is the part where you should copy this in your notes in the homework that I gave you. So I'm going to start with sine. Okay, so the way that I would graph sine in degrees would be like this. So sine has the point 0, 0, and then I'm going to go only to the key points, so it's going to be 90 degrees, 180, 270, and 360. But I'm also going to show you in the negative direction too, because you need to realize that the graph goes in the other direction as well, because I didn't show that before. So I am actually graphing what we call 2 cycles. And I'll tell you what that means in a little bit. So here's my x-axis, and then my y-axis is going from 1 to -1. Again, we have a point at the origin, 0, 0, and then at 90 degrees we go up to 1. At 180 we're back at 0. 270 we're at -1, and at 360 we're back at 0. Again, the reasoning for this is what I did in the first part of the video. Then at -90 degrees we're at -1, at -180 we're at 0, at 270 we're at 1, and then at 360 we are at 0 again. So we get this beautiful curve. Okay, and it does keep going in both directions here. Okay, now I'm going to do the same thing in radians. We will be graphing in both degrees and radians, so I want you to have the parent graphs both ways, because in the beginning you're going to compare back to the parent graphs to graph them. So the only thing that's going to change really is this x-axis, right? Instead of 90 degrees, I'm going to have pi over 2. Instead of 180, I'm going to have pi, then I have 3 pi over 2, and then I have 2 pi, and then in the other direction I have negative pi over 2, I have negative pi, negative 3 pi over 2, and then negative 2 pi. The points stay the same, right? So I start at 0, 0, then I go up to 1, then I go down to 0, then I go down to -1, and then back to 0. And then it kind of follows in the other direction here, so I'm at -1, 0, 1, and 0. Okay, the only thing that changed here is that I'm in radians. Okay, and that's my graph. So now let's talk about the graph of sine here. When you talk about graphs, you usually mention domain and range, so let's start with that. The domain here is all the x values, so you should notice that we could put in anything for x. So that means that the domain is all real numbers, or some of you might write it as negative infinity is less than x, which is less than infinity. The range, though, has some boundaries. So if you look at both the graphs, the range, it only goes from -1 to 1, -1 to 1. So our range is -1 is less than or equal to y, which is less than or equal to 1. And this directly has to do with the unit circle. Remember, on your unit circle, your radius is 1. So when you plug in any angle, it doesn't matter what the angle is, the biggest thing you can get for sine is 1, and the smallest thing you could get is -1. Okay, then I mentioned before that we were graphing here 2 cycles. One cycle would be the part of the graph that doesn't yet repeat. So from here to here is 1 cycle. Because then it starts to repeat, right? This is the same thing. So the period is equivalent to how long it takes to complete 1 cycle. So in this case, it takes 360 degrees or 2 pi. And I'm going to give you notes on period and the rest of the things I'm talking about here. For now, you need to write down what it is for each of the parent graphs. Okay, so then we have amplitude. Amplitude is how big the sine graph is from the sinusoidal axis to the max or the min. So this is actually the sinusoidal axis right here. So how far apart the sinusoidal axis is to the max or the min is going to be the amplitude. So for the parent function, that is 1. It is 1 unit from the sinusoidal axis to the max or the min. I already showed you what the sinusoidal axis is. It's that line that I drew in green here. It basically cuts your sine curve in half. And that is the equation for the x-axis, so that's y equals 0. And what's really important about sine is that you note that sine starts at the sinusoidal axis. And what I mean by starts is that you can start the graph or 1 complete cycle at the sinusoidal axis. Okay, now we're going to do pretty much the same thing, but for the parent cosine graph, and then I'll give you the notes on the side, and then I'm going to give you a little bit more notes on what these specific things are, like the definitions of them. Okay, so now we have y equals cosine x, and I'm going to draw the 2 parent graphs that you should draw on your paper that we're going to keep referring to, 1 in degrees, 1 in radians. So we'll do degrees first. Okay, so that's going to have an x-axis of 90 degrees, 180, 270, and 360. And then in the opposite way, you're going to have negative 90, negative 180, negative 270, and negative 360. Okay, and then we're going to go up to 1, down to -1. So for cosine, if you look back at my table and the graph I made over there, at 0 degrees will be at 1. At 90 degrees will be at 0. At 180 will be at -1. 270 back at 0, and then at 360 will be at 1. And then we continue this. We repeat the cycle on the other side. So at -90, you're at 0. -180, you're at -1. At -270, you're at 0. And then at -360, you're back at 1. So we get this beautiful curve here. Remember, it does keep going. I'm just showing you 2 cycles here. Okay, same thing in radians. We're just going to change the x-axis. So it's going to be pi over 2, pi, 3 pi over 2, and 2 pi. And then you're going to have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We're still going up to 1 and down to negative 1. And the points stay the same. So it's going to be 0, 1. Pi over 2 is going to be 0. Pi is going to be negative 1. Okay, so I'm just really copying from the first graph that I have. Negative pi is negative 1. Negative 3 pi over 2 is 0. Negative 2 pi is 1. Okay, so we have our beautiful cosine curve again. All right, so domain. Domain is the exact same thing as it was for your sine graph. You could put anything in for x, so it's all real numbers, or negative infinity is less than x, which is less than infinity. The range is also the exact same thing for the same exact reasoning. So it's negative 1 is less than or equal to y, which is less than or equal to 1. Your period, or the amount of time it takes to complete one cycle, let's see. So I see a cycle from here to here, and that's 360 degrees. Okay, so our period is 360 degrees, or 2 pi. Our amplitude is still going to be the distance between the sinusoidal axis, which is here again, to the max or the min of the graph. So that's 1 apart again. So our amplitude is 1. Sinusoidal axis, I just marked it out. It's the same thing. Y equals 0, it's the x-axis. And now the important thing for cosine that you remember is that it starts at the maximum value. So if you look back at this graph, the start, I would say, is here, and that started at the maximum. Start is here, that started at the maximum. And that's going to be really important for when we start shifting and transforming the graphs. Okay, so in the next slide, I'm going to give you the definitions. That's also something I want you to write on the homework paper. So here we go. Some of the things I already said out loud, but here's the formal way of writing it. So the sinusoidal axis, that is the horizontal line that cuts, and I'll put that in quotes because it doesn't actually cut, but that cuts the curve in half. Okay, this line will have the equation y equals a constant, just like any other horizontal line. So that if I ask you for a sinusoidal axis, you're going to write it as the equation y equals a number. That number is going to be the horizontal line that cuts, as we would say, the curve in half. Okay, then we have amplitude. Amplitude is the vertical distance from the sinusoidal axis to the maximum point on the curve. Okay, so as long as you pick out your sinusoidal axis first, you can find the distance between that and the maximum point. Then you have your period. Period is the horizontal distance you need to travel before the graph starts to repeat. So basically what this is how long one cycle of the graph is. Okay, so these are all the terms that I already discussed with you. There's one other thing we need to know, which is called a phase shift or displacement. So I'm going to do that in the next slide. So phase shift or displacement, some people call it displacement. That is your horizontal translation. So it's how the graph moves left or right, how it changes from how I said the graphs start. So the start of your graph is when the radians is 0 or the degrees is 0 degrees. Sometimes we're going to shift that left or right. That would be the phase shift. So that's coming next. Now you're going to look at how the graphs are transformed and how it affects the equation. So the rest of the paper, you're going to answer the questions, how you think the graphs change from these parent graphs. And that's why you have the parent graphs on your paper so that you can compare them directly.